Storing and managing data is very important in programming, and in Python, we have 4 built-in data types that are used to store collections of data: lists, tuples, sets, and dictionaries, all with different qualities and usage. Lists are used to store multiple items in a single variable. Lists are created using square brackets. For example, this list equals to square brackets, and let's say we want to specify some strings as the values or items, and maybe those strings could be fruits like apple, and every item should be comma separated in the list. So we'll have another string, and maybe it would be banana, and let's add one more fruit item like cherry. Then we can print this list, run the program, and we'll get the list printed out. Now, one of the distinct characteristics of lists is that they are ordered, changeable, and allow duplicate values. List items are indexed, so the first item has index 0, in this case apple, and the second item has index 1, banana, and so forth. So you could think of it like this: 0, 1, and 2. Now, an index is similar to that of in a book, where you can refer to a book's index to find a word on a specific page. Similarly, in programming, we use the index, in this case in a list, to try to locate where a specific item is allocated. In this case, apple is located at index 0, banana is located at index 1, cherry is located at index 2, and so forth. Now, from a human readability standpoint, we would normally say the first item, which in that case would be like apple, the second item, which in that case would be banana, and so forth. However, because indices start with 0 in programming for data collections like lists, in that case, it's actually the first element is the 0th index, and then the second element is the first index, and the third element is the second index. So it's always like -1. So if we said, like, for example, this list had n elements or n items, and technically speaking, we can keep adding as many items as we want in this list, up to, we would say something like up to n minus 1, where n would be the n items that we could theoretically insert in the list, up to that last item, which would be n minus 1 item from an index standpoint. So for example, if we said this is the 10th item, that would be 10 minus 1, so it would be at index 9. If we said this is the 11th item, then that would be 11 minus 1, and then it would be like index 10, and so forth. Why? Because once again, we start at 0, not at 1. Now, since lists are indexed, they can have items with the same value, which means we can actually allow duplicate values in this list. Like I can have another cherry fruit here. So it would be a duplicate of this item here that we already had. This is allowed in lists. Now, if we want to determine how many items a list has, we can use the len function. So for example, in the print here, I can surround this list with the len function and put this list as a parameter to the len function in parentheses like this, run the program, and then we get 4 as the output. So this is telling us that there are 4 items in the list, which is correct. 1, 2, 3, and 4. List items can be of any data type, not just strings like we have over here. For example, I can create another list, like list 1, and this could be a list of numbers. So 1, 5, 7, etc. And if I get the length of this list, so list 1, run the program, and we get 3, which is correct. The length of this list is indeed 3 because we have 3 numbers. And similar to this list of strings that we have here, the list of numbers here has a similar type of indexing. So 1 is at index 0, 5 is at index 1, and 7 is at index 2, and so forth. We can also have a list that contains different data types. For example, let's create list 2 equals to ABC, a string, maybe a number like 34. We can even have a boolean as well, like true, maybe another number like 40, and so forth. So if we print the length of this list, which is 2, we get 4, which is correct. So we have 4 items in this list. Now, from Python's perspective, lists are defined as objects with the data type list. For example, I'm actually going to change this len over here to the type function and run the program. Notice I get in the output class list. So this is the data type of the list, which is an object. Now, we'll learn more about objects when we get to object-oriented programming, but just keep this in mind, that lists are objects in Python. Now, I have told you so far that list items are indexed. So how can we actually use that to print out specific values instead of the entire list? So what we could do is, for example, let's call this list that we have, and we can index it by just putting a bracket within the print statement after the list name. And then we write in the index that we want to get the value for. So for example, if I want to get banana for this list, that would be at index 1, which means I would have to specify 1 over here, run the program, and we get banana. So this is how you can access lists, by indexing the items in the list like this. Now there's also this concept of negative indexing. Remember I told you that technically speaking, you can keep inserting values up to n-1. So, something like n-1, because we don't know exactly what that last item would be. So we would normally speak it as n-1. So we can take this concept and use it as negative indexing to access items in the list. Okay? And specifically, we can use negative indexing to access the last item in the list and backwards. So here, if I specify -1, run the program, I'm going to get cherry. And similarly, if I say -2, I'm going to get cherry actually again, because we have it duplicated here. And if I say -3, then I'm going to get banana. I added a couple more fruits like kiwi, melon, and mango. And this time, we are going to explore a concept known as range of indexes. So we can specify a range of indexes by specifying where to start and where to end the range. When specifying a range, the return value will be a new list with the specified items. For example, if we want to return the third, fourth, and fifth item, what we can do is we can specify a range here that says 2:5. And what this will do is it will make a search that will start at index 2 right here. And that is going to be included. And it's going to end at index 5, which is right here. And that's not going to be included. So let's run the program and see the output. So we get cherry, cherry, kiwi. So included from cherry, and then kiwi, and then 5 is not included. So 2 to 5. Now, what if we wanted to return the items from the beginning to, but not including kiwi? So what we could do is we could say something like colon and 4. Run the program, and we get apple, banana, cherry, and cherry. So we're getting all the items from the beginning all the way up to kiwi, which we do not include. And this is by leaving out the starting range. And we could do the opposite of that. So we can actually leave the second part of the range and specify the first part of the range, like 2. And if we run the program, we get cherry, cherry, kiwi, melon, mango, which means we skipped these first 2 items, apple and banana, and then we printed out everything afterwards. Cherry, cherry, kiwi, melon, and mango. We can also specify negative indexes if we want to start the search from the end of the list. For example, we can say -4, colon, -1, and then we run the program, we get cherry, kiwi, melon. Now, if we want to return the items from this cherry right here, but not including mango, so all the way up to here, but not including mango, we can also use negative indexes to start the search from the end of the list. So we could say -4 colon -1. Run the program, and we get cherry, kiwi, melon. So these three here without mango. Now moving on, I truncated this list because it was getting a little bit longer. So for the next examples, we'll be dealing with a shorter list to make things a little bit simpler to understand. So we can actually check if an item exists. And to do so, we can use the in keyword. Okay, so for example, if we want to check if apple is present in this list, we can say something like if apple in this list, print yes, apple is indeed in the list. Run the program, and we get apple is in the list. Now, suppose that we had orange instead of apple here. And if we run the program, now we don't get an output. That's because apple is indeed no longer in the list. So this does not get executed. We can also change the value of a specific item in the list. And we can do so by referring to the index number. So for example, if we want to change the second item, banana, we can say this list index 1, because banana is located at index 1, equals to, and we can specify what we want to change it to. So I can change banana to, let's say, orange. And now if we print this list, run the program, we can see that now instead of banana, we have orange as part of the list. Now this is changing one value in the list at a time. But what if we want to replace multiple values in the list at a time? So for this use case, I'm going to actually specify a couple more fruits here in the list: orange, kiwi, and mango. And if we want to change the values of banana and cherry to say something like blackcurrant or watermelon, we could specify in this list here a range from 1 to 3. And we can say blackcurrant and watermelon. Now, if we run the program, so we can see we have apple, blackcurrant, watermelon, orange, kiwi, and mango. Now, I actually want to truncate the list to just the 3 fruits to demonstrate the next example, which is what happens if we want to insert more items than we replace. So the new items will actually be inserted where we specified, and the remaining items will move accordingly. For example, if we want to change the second value, replacing it with 2 new values, in this case, banana, for example, we can say 1 to 2, run the program. And now we see that we have apple, blackcurrant, watermelon, and cherry. So these 2 values here replaced just the one value, which is banana, the second value that we wanted to change. The length of the list will change when the number of items inserted does not match the number of items replaced. So if we insert less items than we replace, the new items will be inserted where we specified, and the remaining items will move accordingly. So for example, if we change the second and third value by replacing it with one value, like if we had 1, 2, 3, and then just simply replacing with one value, like blackcurrant, and run the program, now notice that we have just 2 items. Even though we basically said that we want to replace a value with this value, we are now down to just 2 values in the entire list. Now, in these examples, we have changed a range of item values, but is there a way for us to change them without having to replace existing values? We can do so by inserting items in the list without replacing existing values using the insert method. So dot insert, and the insert method inserts the item at the specified index. So in this case, we want to insert around index 2, and we want to insert watermelon. So if we print the list, we now get apple, banana, watermelon, and cherry. In this case, watermelon has been inserted as the third item. As a result of this example, the list now contains 4 items. Now, what if we just wanted to insert at the end of the list without having to worry about inserting at a specific index? Well, we can do that using what we call the append method. So we can say this list.append, and we can insert something like orange. So this will append orange at the end of the list, so after cherry. If we run the program, that's exactly what we get. Now, suppose that we had another list, call it tropical, and this tropical list will have additional fruits like mango, pineapple, and papaya. So we can append elements from this other list to the current list and use the extend method to do so. So we could say this list.extend, specify tropical. And now if we print this list, we see that basically we extended this list with the second list items, and the elements were added to the end of the list. Now, so far we have been accessing, changing, replacing, inserting, extending, but is there a way for us to remove items from the list? Yes, to do so, we can use the .remove function. So we can say .remove, and we can remove a specific item like maybe banana from this list. Now, when we print this list, we can see that banana is now removed. Now, suppose that we had a duplicate banana here. So let's say we had another banana in the list. And in this case, we are removing banana. So what happens in this case? Would it remove both of them or just one of them? So let's run the program. We see that we actually return back the list with at least one of the bananas still there. That's because the remove method removes just the first occurrence of the specified value. So as soon as it detects a first occurrence, it just removes it, and then that's it. It ends right there, the operation. Now, instead of specifying the element by name itself, is there a way for us to simply specify the index to remove a specific item? We can do so by using the pop method. So I can say this list.pop, and I can pop, for example, index 0, so I can remove apple. And now if we print this list, we get banana, cherry, banana. So apple has been popped or removed from the list at index 0. What happens if I did not specify any index at all in the pop method? Well, what happens is it removes the last item by default. In this case, it would be banana. So if we run the program, we get apple, banana, and the cherry because banana was removed from the end. If we also want to remove the first item from a list, for example, we can use the del keyword or del. So del, this list, and then index it at a specific index. So we want to remove the first item. In this case, it would be apple. Run the program, and we get banana, cherry, and banana. So apple was deleted. If we did not specify the index here, what happens is we can actually delete the entire list. So if I run the program, so we get an error, name error, this list is not defined. So it deleted the list completely. Now, what if we just want to clear the list? So we can use the clear method for that. So this list.clear, run the program, and now we get an empty list. So in other words, the list remains but has no content. List objects have a sort method that allow us to sort the list alphanumerically ascending by default. So for example, I can sort the list alphanumerically ascendingly by specifying this list dot sort. And if I print this list, I get apple, banana, banana, cherry. So now you can see that alphanumerically it's ascending. So A, then B, then C. In this case, we have a banana at the end of the list, but because alphanumerically this banana occurs before cherry, which starts with C, that's why it was rearranged or sorted ascendingly so that cherry is after banana because B is before C. What if this list was a list of numbers? If we run the program, we get the list sorted ascendingly, starting with a smaller number all the way up to the bigger number. So far, we have seen in these two sort examples that we can sort ascendingly by default, but what if we want to sort descendingly? So the larger a number or string or text would be first, and then the smaller would be at the end. Well, in this case, we can specify in the sort parentheses as a parameter, what we say reverse equals true, run the program, and now we get cherry at the beginning with apple at the end. So this is descending order. And the same thing applies for a list of numbers. So we get 100 first, followed by 82, all the way up to 23. Now, by default, the sort method is case sensitive, which means if we had, for example, let's say banana here as a capital letter, and we run the program, we now get B as the first word instead of apple. So case sensitivity sorting can give us unexpected results like this. Luckily, we can use built-in functions as key functions when sorting a list. So if we want a case insensitive sort function, we can use something called str.lower as a key function in the sort parameter. So we can specify key equals str.lower and then run the program. Now we get the correct output. So again, apple is now at the beginning ascendingly, and then banana, banana, cherry. Now, what if we want to reverse the order of a list regardless of the alphabet? We can use the reverse method, which reverses the current sorting order of the elements. For example, we can say this list.reverse, run the program, and we get banana, cherry, banana, apple, which means it basically printed it backwards. Now, suppose that we wanted to copy this list to another list. What we could do is we can use the copy method. For example, if I have a new list called my list, I can set it to this list.copy. And now if I print my list, run the program, I get apple, banana, cherry, and banana, which is basically a copy of this list. Another way instead of the copy method is we can use the list method. So we can say list, run the program, and we are printing the my list, which is a copy of this list, and we get the same list output of values. We can also make a copy of the list by using what we call the slice operator. So for example, this list bracket, and we specify the colon. So this is known as the slice operator in this case. So if we run the program, we print my list, and we can see that we have indeed the same values as this list. Now, suppose that we want to combine or join these two lists together. So there are several ways to join or concatenate two or more lists in Python. One of the easiest ways are by using the plus operator. If we want to join these two lists together, we can have another list, like let's say list new equals to this list plus tropical. Print list new, run the program, and we can see the lists were combined together. Another way, instead of having another list created, we can use the extend method where the purpose is to add elements from this list to the tropical list, or in other words, one list to another. So we can say this list dot extend, and here we are trying to combine it with tropical, and then we print this list, and we can see that we joined the two lists. Moving on to another type of data collection in Python, tuples are used to store multiple items in a single variable. A tuple is a collection which is ordered and unchangeable. Tuples are written with round brackets. For example, we can create a tuple as follows. This tuple equals to, and we use the parentheses or round brackets to specify elements. So in this case, we can say apple, banana, and cherry. And we can print this tuple. So this is the items in the tuple. The distinctive characteristics of tuples versus lists is that tuples are ordered, unchangeable, and allow duplicate values. Tuple items, just like lists, are indexed, and the first item starts at index 0, the second item at index 1, and so forth. So just like lists, indexed like this, 0, 1, and 2. Now, since tuples are indexed, they can have items with the same value. So for example, we can have another apple. If we run the program, we also get that in the output. So in other words, it allows duplicates just like lists. If we want to determine how many items the tuple has, we can use the len function similar to lists. So we can say print len and surround this tuple. in the parentheses of the len function, run the program, and we get 4. And indeed, we have 4 items in this tuple. Now, suppose that I wanted to create a tuple with just one item, like let's say apple. Well, I would still have to leave at least a comma here, even if it's just one item, because if we were to print the type right now with the comma there, we would get class tuple. So this is an object of the class tuple. But if we remove the comma and run the program to check the type this time, notice that we get string instead. So Python will not recognize it as a tuple if you remove the comma if you have just one item at least. Okay, so you have to specify the comma if you want just one item in order for Python to recognize it as a tuple object. Now, tuple items can be of any data types, just like lists. So we can have a string data type, we can have numeric or int data type, we can have a Boolean data type, and so forth. We can even have a tuple that contains all different data types. In this case, we have a tuple of a combination of strings, numbers or integers, and booleans. Now, to access tuple items, we can refer to the index number by specifying the brackets. So in here, we can say that we want to print, let's say, index 1 of the tuple, which is banana. And that's exactly what we get, banana. Now, similar to lists, we can also specify negative indexing, which means that we can start from the end. So for example, if we want to print the last item of this tuple, we can say -1, run the program, and we get cherry. Now, if we wanted to print banana, we can go backwards also with the minus, and we can say -2, for example, and then run the program, we get banana, and so forth. We can also specify a range of indexes by specifying where to start and where to end the range. When specifying a range, the return value will be a new tuple with the specified items. For example, if we want to return the third, fourth, and fifth item, cherry, orange, and kiwi, we can specify a range of 2 to 5. In this case, we don't include the fifth index, so melon. So if we run the program, we get cherry, orange, and kiwi, which is the third, fourth, and fifth items. And remember, from a human standpoint, we don't start from 0, so that's why when I say the third item, which is cherry, it's actually the second index. And when I say the fourth item, which is orange, we actually have it at the third index and so forth. So that's why when we say that we have returned also including the fifth item, in this case, the fifth item is actually kiwi, which is the fourth index, and that's why the index 5 here is not included, which is melon. Now, suppose that we don't specify the starting value. So for example, I just say colon and 4. We get apple, banana, cherry, and orange because we return the items from the beginning to, but not including kiwi, which is the ending range here 4. So remember, the ending range here is not included in the output. Now, what if we do the opposite? So what if we don't specify the ending range, but just the beginning value? So let's say 2, for example. What would happen in this case, we should be expecting that we get a return of the items from cherry and to the end. So cherry, orange, kiwi, melon, and mango. Because remember, the starting value here in the range is actually included all the way up to the ending value, which is not specified here. So that's why we get everything up to mango. We can specify negative indexes if we want to start the search from the end of the tuple as well. For example, if we want to return the items from index -4 included to index -1 and run the program, we get orange, kiwi, and melon. Now, if we want to check if an item exists, so in other words, determining if a specified item is present in the tuple, we can use the in membership operator or keyword. So we can say something like if, and if we are looking for apple in this tuple, if apple in this tuple, colon, and then print, yes, apple is in the tuple, something like that. Run the program, and we get, yes, apple is in the tuple. So apple matches this apple here. Now, what if we did not have apple? Instead, we had maybe oranges. And run the program. Now we don't get any output because this did not match any of the items in the tuple. Now, once a tuple is created, you cannot change its values. Tuples are unchangeable or immutable, but there is a workaround. So we can actually convert the tuple into a list. And because we can change lists, so we can actually change the list and convert the list back into a tuple. For example, for this tuple that we have here, we can have, let's say, another tuple, maybe tuple second, something like that, and set it to list of this tuple. Then we can say tuple second 1 equals to, so I'm trying to change here, let's say banana to kiwi. Then we can say this tuple equals to tuple second. And then finally we can print this tuple to check if we have now kiwi instead of banana. And indeed, we now have kiwi instead of banana. So what we've done here is that we have converted the tuple into a list using the list keyword. And then after that, we changed value of banana to kiwi through the list that we have created through this conversion here. And then after that, we converted back to a tuple. And now we printed the newly changed tuple, which contains kiwi instead of banana. Now, since tuples are immutable, like I mentioned, they do not have a built-in append method to add items like lists do. So there are other ways to add items to a tuple, however. We can convert into a list like we did right now, and by changing it to a tuple, we can convert it to a list, add the item, and then convert it back to a tuple. For instance, instead of changing the item over here, we can say tuple second dot append, and let's say that we want to append oranges, and then we convert back the tuple. So now if we run the program, we now get apple, banana, cherry, and oranges. So this way we added an item to the tuple by doing the conversion to a list and back to a tuple. Another way is we can add tuple to a tuple. So if we want to add one item or many, we can create a new tuple with the items and then add it to the existing tuple. To do so, we could do something like this, where tuple second is equal to, say, orange. And remember, because we are adding one item, we need to have a comma. And then we can say this tuple plus equals tuple second, then print this tuple. Run the program, and we get apple, banana, cherry, and orange. Now, because tuples are unchangeable, we cannot remove items from them, but we can use the same workaround that we used for changing and adding tuple items. So we can convert the tuple into a list and then remove an item, like let's say apple. So I'm going to say here tuple second dot remove apple, and then we convert it back into a tuple. Now, if we run the program, we can see the apple was removed from the tuple. Now, if we don't want to convert it, that's fine. We can just use the del keyword to delete the tuple completely. So del this tuple. Now, if we run the program, we should be expecting to get an error because now the tuple no longer exists, so it's deleted completely. Now, when we have created this tuple of fruits, we normally assign values to it, like apple, banana, cherry, etc. We call this packing a tuple. In Python, we are also allowed to extract the values back into variables. We call this unpacking. So if we want to unpack the tuple, we can do the following. Parentheses, green, yellow, red equals to fruits. And then we can print, say, green, print yellow, and print red. Oops, this should be yellow here. Run the program, and we get apple, banana, and cherry. So the number of variables that we have defined here must match the number of values in the tuple. In this case, there are 3 values, so we have to have 3 variables for unpacking. For example, suppose that we had additional fruits in the tuple, say strawberry, raspberry. We can add an asterisk or a star symbol to the variable name, and the values will be assigned to the variable as a list. So I can add an asterisk over here behind the red variable, and this way we assign the rest of the values as a list called red. So run the program, and you can see here that we get apple for green, and then banana for yellow, and then for the asterisk red variable, we get the rest of the tuple as a list. What happens if instead of putting the asterisk here in the last variable, we put it on the yellow? Well, what will happen is that Python will assign values to the variable until the number of values left matches the number of variables left, like we see here. And then finally, with the last variable that we have, which is red, it assigned it to the last value in the tuple, which is raspberry. Now we can actually join 2 or more tuples using the plus operator. I can define here a tuple 3 and set it to tuple 1 plus tuple 2, then print tuple 3 on the program, and we can see that both tuples, tuple 1 and tuple 2, were combined in this case. Now, if we want to multiply tuples, we can multiply the content a given number of times using the times or asterisk operator. So we can say, for example, my tuple equals to fruits times 2, print my tuple, run the program, and you can see that because we multiplied it twice, so we got the resulting tuple with double the values. So if we were to multiply it 3 times, then we can get it with triple the values, and so forth. Now moving on to sets. Sets are used to store multiple items in a single variable. A set is a collection which is unordered, unchangeable, and unindexed. Sets are written with curly brackets. So for example, to create a set in Python, you can say the set equals to curly braces, and then we can say apple, banana, and cherry. Then print the set on a program, and we get the set printed out. One of the distinct features I mentioned about sets is that they are unordered, which means we cannot really be sure in which order the items will appear. So even though I have apple, banana, and then cherry, notice that in the apple I got apple, cherry, then banana. And if I run the program again, the order might change again. And indeed it did. So now we have banana, then cherry, then apple. Now, unlike lists, which can have duplicates, sets cannot have duplicates. So if I added cherry, for example, here, and I try running the program, you can see that I don't get the duplicate outputted. In this case, the duplicate will get ignored. Now, we can, of course, combine other data types within the set, like booleans and numbers, like 1, 2, true, etc. But specifically with booleans, we did say that sets cannot have duplicate values, right? They will get ignored. So what if I had here true, and because I also have 1 here, so remember true is also 1, and the same thing with false. False is also 0, right? Python considers this actually as a duplicate. So 1 here is actually a duplicate of true. And so if we run the program, we get 1, apple, 2, cherry, banana, but notice that we don't get true because Python considered this as a duplicate to true, so that's why it only included 1. Now, if we want to determine how many items the set has, we can use the len function. So len and surround the set in the print, run the program, and we get 3. And that's exactly what we have. We have 3 items in the set. Now let's check the type of the set and see what Python considers it. So from Python's perspective, sets are defined as objects with a data type set. Now, unlike lists and tuples, we cannot access items in a set by referring to an index or a key. Instead, there's a workaround, which is using the in keyword. So we can say banana in this set, run the program, and we get true. Of course, we can also use the not in membership to determine if banana is not present in the set. If we run it, we get false. Why? Because banana is actually present in the set. Another limitation is that once a set is created, we cannot change its items, but we can actually add new items. To do so, we can use the add method. So I can say this set.add, and we can add, say, orange, and then print set, run the program, and now we get cherry, orange, banana, and apple. So orange was added to the set. Now, suppose that we have these two sets, this set and this tropical set, and we want to add items from one set to another. We can use the update method. So I can say the set.update, and I can include the tropical set here, and print the set, run the program, and you can see that we get cherry, banana, papaya, mango, apple, and pineapple. Okay, so this is the way we can add items from one set to another. Now, suppose that we want to remove, let's say, banana from the set. So for that, we can use either the remove or discard method. Let's see how we can do that with the remove method. So we could say this set.remove and specify banana, run the program, and now we don't have banana anymore in the set. However, if we try to remove an item that does not exist in the set, let's say like oranges, we will get an error. So we can use the discard method instead, which is a little bit safer. This way it would not raise an error if the item does not exist. And if the item does exist and we want to remove it, for example, like apple, then the discard method will remove it. We can also use the pop method. For example, x equals the set.pop, print x, run the program. So in this case, we are popping apple, right? But if we run the program again, now this time it pops cherry. So with pop, it's unpredictable. It basically removes a random item, so we cannot be sure what item gets removed. And again, the reason for that is because, remember, sets are unordered, which means when we use the pop method, it wouldn't know which item that gets removed. It's all random. We can also use the clear method to empty the set completely. So this set.clear, run the program, and now we get an empty set. If we want to delete the set completely, we can also use the del keyword or del and delete the set, run the program, and this time we get an error. This set is not defined because the set was completely deleted. Now we can also join sets, and there are several ways to join two or more sets in Python. We can use the union method, which returns a new set with all items from both sets. For example, I can specify a set 3 here and set it to set1 dot union of set2, and then print set3, run the program, and here we get the union of both sets. Also, instead of the union method, you can actually use the pipe operator to specify the union, and it will give us the same result, the union of the two sets. Now, of course, you see the output here is different than the previous output because, again, sets are unordered, so the output is always going to be ordered differently. But the idea here is the same. We were able to join both sets. Now, suppose that we had another set like set XYZ, and we want to also add it to these two sets. Well, again, using the union method, we can simply just specify, let's say, set2 and set XYZ, run the program, and we get all the sets combined. We can also replicate the same thing using the pipe operator as well. So I can say set1, pipe, set2, pipe, set XYZ, and we get a similar output. Now, the union method also allows us to join a set with other data types like lists or tuples. So for example, if I have a tuple here, tuple ABC, I can also join it with the sets here. So tuple ABC, run the program, and you can see that we get the tuple values included as part of the larger set here. However, we cannot do this with a pipe operator. So for example, I cannot say set1 pipe tuple ABC and run the program. Instead, we're going to get an error, unsupported operand. So if you want to combine with other data types, the union method is the way to go. Now, suppose that we want to insert all items from one set into another set. Okay, so let's say I want to insert all the numbers 1 to 3 into set 1. Well, I can use the update method to do that. So I can say set1 the update and set2, run the program, and now we have all the numbers in set2 inserted into set1. Now, both the union and the update methods ignore or exclude any duplicate items. So for example, if we had, let's say, cherry here, and let's say I had cherry in set2 as well, and I run the program, notice that we don't get cherry outputted more than once. And the same thing applies to the union as well. Now, what if you have a use case where you want to include only the duplicates? Well, we can use something called the intersection method, which will return a new set and then only contain the items that are present in both sets. So for example, I can create a set 3 here and then say set1 dot intersection with set2 and print set3, run the program, and you see that we get cherry, which is what is common between the two sets, set1 and set2. By the way, instead of the intersection method, I can also specify the ampersand operator, which is like the and here I can say and set2, run the program, and we also get the same result, which is a cherry, the duplicate. Now, just like the pipe operator, the ampersand operator here only allows you to join sets with sets and not with other data types like you can with the intersection method, like tuples and lists. We can use what is called the intersection update method to keep only the duplicates, but change the original set instead of returning a new set. For example, set1 dot intersection underscore update and set2, then print set1. We run the program and we get cherry. So this is essentially changing the original set instead of having to create a new set like set3 like we did previously. Now, what if we want to return a new set that contains only the items from the first set that are not present in the other set? For that, we can use what's called the difference method. So, for example, I can specify set3 equals to set1 dot difference set2, and then print set3, run the program, and here I get apple and banana. So in this case, we are keeping all the items from set1 that are not in set2, which is apples and bananas. Cherry is present in set2, so in this case, we only print apple and banana. Instead of the difference, we can actually just say set1 minus set2, and we'll get the same result as well, apple and banana. However, keep in mind that the minus operator, unlike the difference method, only allows us to join sets with sets and not with other data types like tuples and lists. Now, similar to the intersection update method, we actually have a difference update method which will keep the items from the first set that are not in the other set, but change the original set instead of returning a new set. So instead of having like set3, we can literally just use set1 dot difference update and set2, and then print set1. And we get banana and apple. So similar result. There's also the symmetric difference method, which will keep only the elements that are not present in both sets. So in other words, I can have set3 equals to set1 dot symmetric underscore difference set2, print set3, run the program, and we get 1, 2, 3, banana and apple. So in this case, the cherry is the common item, so we don't include it. And by the way, instead of this symmetric difference method, we can actually use what's called the caret operator, which is this symbol, to represent the same behavior. And that's exactly what we get. 1, 2, 3, apple and banana, which means cherry, which is the one that's common between the two sets, was ignored or not included. Now, similar to the other operators, the caret operator only allows you to join sets with sets and not with other data types like tuples and lists. Now, instead of having to create a set3 like this, we can actually just use set1 and use what's called the symmetric difference update method, which will keep the items that are not present in both sets. So let's run the program, and we get 1, 2, 3, apple and banana. So this way we don't have to introduce a new set3. Moving on to the next data type collection, we have dictionary. Dictionaries are used to store data values in key value pairs. A dictionary is a collection which is ordered. That's actually as of Python version 3.7. In Python 3.6 and earlier, dictionaries are unordered and changeable and do not allow duplicates. Dictionaries are written with curly brackets and have key and values. For example, to create and print a dictionary, this dictionary equals to curly braces, brand. So in this case, the brand would be the key, followed by colon, and we specify the value like Ford. We can have another key like model, colon, followed by something like Mustang. And we can have another key like the year, maybe like 1964. And then we can print this dictionary, run the program, and we get the brand, Ford, model, and the values that accompany each key. Now, duplicates are not allowed. So for example, if I had year here and like 2020, and I run the program, notice that the year 1964 was actually excluded from the dictionary that we have outputted here. So in other words, duplicate values are overwritten. Now, if we want to determine how many items a dictionary has, we can use the len function. So here I can say len, this dictionary, run the program, and I get 3. Now, the values in the dictionary can actually be of any data type. I mean, notice that we have so far here string data type, a number data type. We can have Boolean data types. We can even have actually list data types as well in the dictionary. So I can say something like colors as a key and make it a list of colors like red, blue, etc. Now, we can determine the type of the dictionary by using the type function and run the program, and we can see that dictionaries are defined as objects with the data type dictionary. Now, we can actually access the items of a dictionary by referring to its key name inside square brackets. So here I can say this dictionary, square brackets, and specify, let's say, the brand key, run the program, and we should be expecting to get Ford as the value. So that's how we can access the dictionary items. There's also a method called get that will give us the same result. So for example, I can say this dictionary.get, say I want to get the model, run the program, and I get Mustang. Now, what if I want to return all the keys, the brand, the model, and the year of the dictionary? Well, for that, I can use the .keys method. So I can say this dictionary.keys, run the program, and I get all the dictionary keys. Now, what happens if I add a new item to the dictionary? So for example, if I have a variable x equals to this dictionary dot keys, and then let's print what it is before the change. And then now I'm gonna insert or add a new key. Say for example, color, and I want to set it to maybe white. So now let's print x. So this is after the change. Run the program, and you can see that before the change, we had the brand, the model, and the year. And after the change, now we have the color included. So the list of the keys is a view of the dictionary, meaning that any changes done to the dictionary will also be reflected in the keys list. Now, just like we were able to query or get the keys of the dictionary, we can also get the values specifically of the dictionary. So we can say x equals this dictionary dot values and print x. Run the program, and here we get the values, Ford, Mustang, and 1964. If we made any change to the dictionary, we will see that the values list gets updated as well. So for example, this is before the change. And let's say we are trying to change the year from 1964 to 2020. So this dictionary year equals to 2020. So now if we print X after the change, run the program. So you can see that the original one was 1964, and now after the change is 2020. So in other words, the list of the values is a view of the dictionary. So any changes done to the dictionary will be reflected in the values list. What if instead of changing the year, I wanted to add a new item to the dictionary? Okay, so for example, this dictionary, color equals to red, run the program, and we will see that adding a new item to the dictionary, that the value list gets updated as well. Now we can actually use the items method to return each item in a dictionary as tuples in a list. So here I can specify the items, run the program, and we can see that we get tuple in a list. Now this returned list is just a view of the items of the dictionary, so any changes done to the dictionary will be reflected in the items list as well. For example, adding like color key and setting it to red. If we run the program, you can see that the change was also reflected. Now, to determine if a specific key is present in a dictionary, we can use the in membership keyword. So we can say if model in this dictionary, print yes, model is in the dictionary. Run the program, and we get yes, model is in the dictionary, which actually it is. What if we try to search for color and run the program? Now, obviously we don't get any output because color was not in the dictionary at all. So this makes sense. Now, we've seen this slightly earlier, but again, if we want to change the value of a specific item, we can refer to its key name. So we can say, for example, this dictionary, and if we want to change the year, we can refer to the key year, and then set it to a new year, like maybe 2020. Another way we can update the key year in this case is we can use the update method. So for example, I can say this dictionary dot update. And the argument for the update method must be a dictionary or an iterable object with key value pairs. So in this case, it would be a dictionary like this, where we have the key year followed by the value that I want to update it. So from 1964 to like 2020. There are several methods to remove items from a dictionary. We can use the pop method to remove the item with a specified key name. For example, this dictionary dot pop. We can specify maybe we want to pop the model. So now if we print this dictionary, we're going to see that the model was popped from the dictionary. Now, if you don't want to specify an item, what you could do is you can use what's called pop item, like this. And what this will do is it will remove the last inserted item from the dictionary. So in this case, it would be the year, right? Run the program, and that's exactly what we get. Brand, model, and the year is missing. However, in versions before Python 3.7, a random item is removed instead. Python 3.7 and forward, the last item is guaranteed removed instead. We can also use the del or del keyword to remove item with the specified key name. So for example, del, this dictionary, say model, run the program, and the model was removed. We can also delete the dictionary completely. So if I run the program, we should be expecting to get an error because now the dictionary is completely deleted and removed from the program. We can also use the clear method to clear a dictionary. So this dictionary.clear, run the program, and now the dictionary is empty. Now, if we want to make a copy of dictionary, what we could do is we could create another dictionary, like my dictionary. This dictionary dot copy using the copy method. Now print my dictionary, and we get the copy of this dictionary. We can also make a copy using the built-in function dict. So we can say my dictionary equals to dict, this dictionary. Run the program, and we get a copy as well. So to summarize, Python has multiple data type collections, which are in other languages known as arrays, basically. These 4 collection data types are lists, tuples, sets, and dictionaries. Lists are a collection which is ordered and changeable and allows duplicate members. Tuples are a collection which are ordered and unchangeable. They allow duplicate members as well. A set is a collection which is unordered, unchangeable, and unindexed. And with dictionaries, which we just covered, these are a collection which is ordered and changeable. No duplicate members. Remember though, as of Python version 3.7, dictionaries are ordered. In Python 3.6 and earlier, dictionaries are unordered. When choosing a collection type, it is useful to understand the properties of that type. Choosing the right type for a particular dataset could mean retention of meaning, and it could mean an increase in efficiency or security.